I know we've done a couple of these today, but I'm still going to go over this stuff because, I think it's good, okay? So, just like we have done before, we'll start with one of the inequalities, right? So that we don't have to focus on both and get kind of razzled by seeing so many. So we'll distribute this 2 times 3x, which will give us 6x's, and then 2 groups of 7 is 14 right there. That's less than or equal to 2. So we'll isolate the x's by subtracting 14 from both sides. That zeroes that out, which is what we want. Now we got 6x is less than or equal to, now it's negative 12. Now even though we're dividing by 6 on both sides, that second 6 didn't come up. It keeps glitching on me. There we go. To make that a phantom 1, it's dividing by a positive, you guys. So even though the 12 is negative, it's dividing by a positive, which means it does not flip that inequality. So I get x is less than or equal to negative 2. And also, we get this other one here, where, we'll solve this one. And again, I'll do this in one step. We'll do 2 steps in one here. And you guys like the x's on the left, which is good. You can do that. So I'm going to keep them on the left, which means I'll get rid of this positive 4, so I'll subtract 4 from both sides, while simultaneously getting rid of that positive 8x. So I'm going to subtract 8x also from both sides to zero that one out. And the 4, negative 7x minus 8x, that's going to give us negative 15x. And then this is less than 49 minus 4 is 45, so this is going to work out real nice. Divide both sides by negative 15. And this is where we have to be careful because I did divide by negative in this case, which does flip that inequality. So that's 1x now. X is greater than or equal to negative 3. 45 divided by negative 15. And this was an and statement. So when we put this out on the graph, and I'll put an and between that, even though we'll change it up probably depending on the graph. I don't know where I was going with that, but I'm going to graph it, okay? So I'm going to start with the red. X is less than or equal to negative 2, so we got 0, negative 1, negative 2, negative 3, right? And so x is less than or equal to negative 2. So that's a closed circle at negative 2 because it's equal to the negative 2. It's not eating the x, so I know this one goes to the left. Now that's as far as I'll take this one because I'm looking for the intersection between the two, right? And for the x and negative 3, it's an open circle because it's not actually equal to negative 3. This one is eating the x, so this one goes to the right. And so we can see the intersection between the two would happen between negative 3 and negative 2. I mean, I've drawn this a little bit differently, right? Like if you guys were like, hey, put the line down here, it's the same thing, okay? So wherever you put those lines, just so you know where they are. I mean, when you graph them on the homework, it doesn't matter, we'll do it for you. But this would be the whole graph, right? We don't really need those parts that kind of drift off to the left or the right in either direction. We don't need those parts because we're only looking for the intersection. Well, if that's the graph, then what's the interval? Well, it starts at negative 3. It's not included, and it goes all the way to the right so far to negative 2, which is included, so we get a square bracket. Now, what this means as well is that we could change the inequality to be a little bit more compact, right? Compounded. So we'd say, well, x as far to the right is negative 2, right? Which it could have equaled negative 2, but it's less than that. And then when we compare with negative 3 like this, again, in purple there it was still eating the x. So when I compare with negative 3, it still needs to eat the x. And that would simplify that, I suppose, into a more compound inequality.